Alright guys, so this is our Unit 1 for the first exam for Math 1. A lot of the skills in Chapter 1 have to do with things that we've been taught in the past, and we didn't necessarily spend a lot of time doing them in class. So I want to try and make sure that we're all squared away on what we need to know for the test in terms of old skills. So I kind of created an essential review that walks us through many of those things that we need. So you can see here, be sure to read the instructions for each problem, know what you're trying to do, be neat and organized. I've provided these little boxes. That's kind of the way our exam is structured. Each question's in a box, so we want to make sure we're working neatly and showing all our work. I don't care how easy you think a particular step is, make sure you're showing your work. It's really important to make sure you get full credit and so you don't get lost with your own process. So, okay, we're just going to run through these. There's about a dozen of them, so we'll get started. Number 1, what value of p makes the equation true? So another way they could have phrased this question was solve for p. Okay, what value of p could I plug in that's going to make this true? So what we always want to try and do when we have an equation is look to see if there's anything we can reduce or simplify or combine on one side. So if I look on the left side, I see two constant numbers here, which I can jam together and combine. So 3p minus 9 and plus 29. So the 3p stays the same. Minus 9 plus 29 becomes a plus 20. Likewise, let's see if there's anything on the other side that we can stick together. So I see actually a p here and a negative p there. So if I have one p and then I subtract it, those will actually reduce to 0. So those cancel each other out. And then I see I have a constant here and a constant here on the same side. So 8, positive 8 and 3 is 11. So I haven't actually done anything to change the value of either side. I'm just combining the stuff that's similar, so that's alike, so I can make it easier to read. And now I need to solve using my steps of equality, rules of equality. So I want to try and get all the constants on one side, all the variables on the other. So my p's are already all over here, but I need to get this 20 to the other side. So I'm going to subtract it away from both sides. That will reduce to 0. So on this side, I'm left with a 3p. 11 minus 20 is a negative 9. And I'm almost there. Now to get the p all by itself, I have to divide away the 3. 3 over 3 is 1, so I've made essentially the p all by itself. But what I do to one side, I have to do to the other. So my final answer, the p, is equal to negative 9 over 3, which if I simplify that, stays negative, and 9 divided by 3 is 3. That's the only number, negative 3, that I could replace all these p's up here with, and my scale would stay balanced. Okay, question 2, solve for x. So this one's a little bit closer to being solved when we start, so that's a good thing. Again, we want to get all the x's on one side and all the, or whatever the variable is, and all the constants on the other, and we do that using our process of moving things around with our properties of equality. So sometimes, I like to think of it as a scale. So there's my scale. Both sides are even. So what I do to one side, I have to do to the other to keep it even. So I'm going to subtract 8 from this side because I don't want the 8 with the x. I want the 8 away from the x, so I got to get rid of it. 8 minus 8 is 0, so that goes away. And I end up with just a negative 4x on this side. And I have to do things equally. So what I did there, subtracting 8, I have to do to the other side to keep my scale balanced. So 52 minus 8 would give me 44. Negative 4x equals 44. So I need to get the x by itself by dividing away this negative 4. Right? Negative 4 over negative 4, that's a 1. Right, that's like 1x. And I do the same to the other side, divide by negative 4. So I'm left with just the x on the right side, and now I can reduce 44 divided by 4 is 11, and one of them was negative, so it stays negative. Number 3, solve for x. And again, if I'm going fast or you missed something, the beauty of the video is you can go back and check it again, or you can always certainly ask me, but I want to make sure we kind of at least cover all these in a reasonable amount of time. 3x plus 7 on the left. Remember we said on our first problem we want to see if there's anything we can do to combine terms to make it simpler. 3x and 7, I can't combine those. The 3x has an x, the 7 doesn't. On the right side, I see here I have a 2x plus 9 plus x. So there's two things on the right side with x's. That means I can go ahead and combine them. So the 2x and the 1x become 3x plus 9. Right, the 9 comes down, and over here 3x plus 7. So now I again want to get all the x's on one side, so I'll subtract them away from the right hand side. I could have picked either one. Do the same over here, and this leaves me with just a 9. This leaves me with just a 7. So I get 7 equals 9. And you're probably looking at that and wondering, how is that possible? Well, it's not possible. So that means there's no solution. If I ever get an answer where, the final outcome of all the work I did, if I do it all correctly and I get an answer that looks like 7 equals 9 or one number equals another, then that means that are not the same number, then that means there was no solution. There's no value of x I could plug in up here that's ever going to make this scale balanced. So I'm going to pause the video here and make another section for the other problems, and then we'll pick it up there.